Let's look at how we can write this system of equations as an augmented matrix and then use technology to find the row echelon, reduced row echelon form, and also the solution for the system. So first, writing this as a matrix, we're going to use the coefficients for each of our variables. So 2, -4, and -6 from equation 1 with our constant of 2. We have 1, -3, 1, and 12. And then 2, 1, 3, and 5. So now I want to input this matrix into my calculator. So on the TI-83 or TI-84, to get to the matrix menu, you're going to hit second and then the X inverse button. So here you'll notice this is really 3 menus. We're going to use the right arrow to go to edit and choose to edit matrix A. So first I need to tell the calculator the dimensions of my matrix. So this is a 3 by 4 matrix. And now we want to input the values from our matrix. So we have 2, -4, -6, and 2. We have 1, -3, 1, and 12. So just hit enter in between each entry. Be sure that you're using the negative button and not the subtraction key as well. And 2, 1, 3, and 5. Once we get our matrix into the calculator, we want to go back to our home screen. We can do that by hitting second and mode, which takes us to quit. So from the home screen, now we can tell the calculator what kind of math we want to do on this matrix. So I'm going to go back to the matrix menu now. So second and matrix. This time I'm going to choose math from the menu. Sorry. So we want to find the row echelon form. So I'm going to scroll down. I'm looking for the one that says REF. So we're going to use this one first, then we'll look at the RREF. So REF stands for row echelon form. So now we want to tell the calculator what matrix we want it to put into row echelon form. So hit second and matrix again. And here from the names menu, just hit enter to select matrix A. So this is saying it's going to take matrix A and put it in reduced echelon form. So you can see here our matrix has 1s on the diagonal with 0s below each of those 1s. So let's write that down. So REF. Of 1, -2, -3, and 1. 0, 1, 1.8, 0.6, 0, 0, 1, and 2. If I were going to use this to solve my system, I would start here in the third line, and this is telling me that z is equal to 2, and then I would back substitute, take that into equation number 2, which is saying that y plus 1.8z is equal to 0.6. I'd plug in 2 for z and then solve for y. Once I knew y and z, I could plug back in to find out my x. We can actually use the calculator, though, to avoid this back substitution by using reduced row echelon form. So go back to your matrix menu, second matrix. This time from the math menu, select RREF. This stands for reduced row echelon form. And then do second in matrix and select matrix A again. This time, it's going to put it in reduced row echelon form, which means that we have 1s on our diagonal and 0s both above and below. So let's jot that down. So for RREF, we came up with 1, 0, 0, 1, 0, 1, 0, -3, 0, 0, 1, 2. So looking at this, this is telling us that z is equal to 2, y is equal to -3, and x is equal to 1, because remember your columns represent x, y, and z. So now we can write as an ordered triple 1, -3, and 2. When we're working by hand, we generally use row echelon form because it's easier to do the calculations by hand to get it in this format and then use back substitution. But if we're using our calculator, there's really no reason not to use the reduced row echelon form, so we can go straight to our solutions based on that simplified matrix.